All right, welcome everybody. Your next homework assignment is due on Monday, and remember that since this Friday is not, we won't have class on Friday because it's spring break, and so I won't be holding my usual office hours on Friday, but if you do have questions on the assignment, you can still contact me. Even though I'm not going to be in the office that day, I'll have Teams running on my phone, and you can send me emails and all that. So if you need any help on homework 8, be sure and let me know. The other thing that should be on your mind these days is the project, and that's due on Wednesday the 21st. And I've said it before, but I'll just repeat it, that this is not something that will go well if you procrastinate. It definitely needs some advanced thought, and you need to give yourself the opportunity to ask questions if you face uncertainties on how to apply the instructions that are in that assignment description. All right, now today we're going to continue with incremental analysis. The lecture that we had on Monday, class 22, we did incremental internal rate of return analysis, and the really important thing that you need to take away from that lecture and the in-class exercise is the order in which you do the incremental comparisons, because the idea of incremental analysis is simple, but what's also really important is that you are able to do the matchups in the correct order and know when to reject one option and move on to the next. Now let's talk about a spin on incremental analysis. Sometimes we acquire equipment that's used in business, and we utilize that equipment on an ongoing basis, and we replace it a lot. So just an example of that would be laptops. It's not uncommon for the replacement cycle on laptops to be just 2 or 3 years. And so rather than thinking of it as a permanent investment that lasts for a really long time, sometimes we'll just determine the annual worth of equipment. And so what that means is we can, just in the same way that we can do present worth analysis or future worth analysis, we can find the equivalent annual worth of equipment, and we may want to compare the alternatives on an annual basis. So this incremental annual worth analysis is combining two ideas. It's combining the ideas of comparison of the added cost between the cheaper and the more expensive alternative, and wanting to know on an annual basis what is the rate of return on the difference between the two. So we're going to solve for some unknown interest rate, and that's what we did in class on Monday when we were saying let's have the more expensive alternative minus the cheaper alternative. And so we found the increment, and the way that it worked in Monday's class was there was an incremental additional cost at the present and then additional revenue in the future. But in the case of annual worth analysis, we combine both the revenues and the costs together and find the annual equivalent between the two. And so we're still going to be solving for an interest rate, but the assumption that we apply with annual worth analysis is we assume that we can repeat these alternatives. And the advantage of using the annual worth method is that then you don't have to bother with things like least common multiple or the early termination or the option of contract services. You remember that those were some of the approaches we applied when we were trying to make cash flow diagrams match up and end in the same number of years. When you use annual worth analysis, you just assume that you can go out and find a replacement anytime you want. And in the case of laptops, that is pretty much true, that if you're willing to spend $1,000 for a laptop, you'll always have a pretty good laptop now and 2 years from now and 2 years beyond that, just because the technology keeps getting kind of more effective for the same price. All right, so the method is going to be kind of demonstrated in this comparison that we're going to do between two different front-end loader options, a cat and a bobcat. And you can see that option B is more expensive up front. It has a higher initial cost, but in exchange for that, it has a lower annual cost, just $1,600 in annual expenses compared to the higher, this is all hypothetical, but the higher annual cost for the bobcat. And then we're going to see what if they have different useful lives. So we're using the annual worth analysis because of that different useful life issue, and it allows us to just ignore it altogether. When we calculate the annual worth, then we can compare options that have different useful lives, and there's no problem with that. So what we're going to do for both of these is we're going to find the incremental, the rate of return on the difference. And so you'll see that option B is more expensive up front, and we want to know what's the rate of return on the additional $5,000 that you would have to spend in order to buy the more expensive alternative right now. And to solve this in class exercise, we're going to use a template. Let me just take a moment to email you that so that you don't have to type in all of the formatting, and because there's quite a lot of text there. So let me just track down the template file and send you that via email real quick. So here's the file that I hope you have printed out for today's in-class exercise. It's got a description of the options, and the procedure is explained. And so A through G, I'm basically talking you through how to use this template file that has just been emailed to you. So what I'm going to do is I'm going to pause for a moment, and I'd like to see if, based on the instructions that are given here in the A through G, if you can find out how to calculate the incremental rate of return. And remember, we're not trying to find the rate of return of each option individually. We want to know what's the rate of return of the extra amount that's required to purchase the more expensive alternative. So the initial cost is lower for option A compared to option B. This method gives you a way of finding out the costs on an annual basis, and then by changing some guess value of the internal rate of return, you're going to minimize the difference of those costs down to zero. So that's the procedure that is explained in these steps, and the way that the reason why we've got this kind of gap between option A and option B is you're going to find the sum of the costs for both alternatives and then the difference between those costs. And then as you change the discount rate that's used for the delta I star, you're looking for, your goal seek, convergence here, is the difference of the costs to be equal to zero. All right. So I'm going to pause for a moment, give you some time to read through. Did everybody, by the way, has that email come through that has the template file in it? Okay, good. Thank you, Trey. All right, I'm going to pause the recording. Okay, I think that people are starting to have finished the calculations, and so let's go through these steps together and see if we can figure out what the right answer for this is. Let me just try and arrange the two windows so that we can see both the instructions and also the calculations at the same time. Alright, so you've got the student start file. Initial guess value for delta I star, and we don't know what the rate of return is on the increment yet, so let's just put in 1% as a placeholder, and we'll come back to it later. Alright, so option A is a lifespan of 10 years whereas option B has a lifespan of only 5 years. Okay. The initial cost of option A is 8,000. So I'm going to put in minus 8,000, whereas the initial cost of option B is 5,000 more than option A, meaning that it is 13,000. Okay. Now the annual equivalent of the initial cost, this is just a P value right now, and we want to find A given P. And so what this instruction says is we can use the payment function based on the initial guess value of delta I star. Okay, so we're going to use the payment function. What payment does is it finds, it's basically find A given either P or F. So when we start the payment function, PMT, first ask for the rate. So I'll click here on the rate, and I'm going to anchor that reference because I'm going to copy the formula over into the column for option B. So anchor the reference. The N value is 10 years, and then comma. I could type in either the next amount can be defined as a present value, or if I skipped over that, I could tell it what the future value is, and then it would find the payment, meaning A, based on a future value. But what I have as an initial cost, that's a present value. So I'm going to refer here to the 8,000, and I need to put in the minus sign, otherwise it'll flip the negative to positive. And I'm just going to keep these all as minuses because it's outflows. But I mean, I guess we already know that they're costs, so that by definition tells us that it's outflows. But as long as we're consistent through the problem, then we'll be okay. All right. So at 1%, then that means that converting this 8,000 to a 10-year A is making it $844. So, I mean, that makes sense, because if it was 0%, then it would just be 800. And so when you're using 1%, then what it's doing is the amount, as it goes forward and through time, then the amount is increasing. Okay, so now let me do the same thing over here for option B. I'm just going to take this formula, I'm going to copy it. So actually, I'll just click on the cell, Control C to copy, and then get to this location, Control V, and I think I need to adjust the width of that column for it to be able to show the amount. Okay, so it's still using this guess value of the interest rate. The N value is the lifespan, and this lump sum initial cost is a present value. So it's finding A given P. All right, now the annual costs are defined in the problem statement. Annual cost of $3,500 for option A. And then option B, we know, is $1,900 per year less to operate than option B. So I guess I could say this amount plus 1,900, because it's 1,900 less to operate. So it means 3,500 a year to operate versus 1,600 per year. And that's what we had in the spreadsheet, right? Annual cost 1,600 versus annual cost 3,500. All right. So this is already annual. And now the salvage value, option A has no salvage value, but option B has a salvage value of 2,000. And this is where I'm making it positive, because when you sell something you get the money, whereas all the rest of these things have been costs. And so the salvage value annual equivalent, well, it's 0 for option A. But for option B, now I'm going to do the payment function again. Here the instruction list says find the annual equivalent of the salvage value, but this time the lump sum amount is a future, not a present. So this 2,000, if we visualize, by now hopefully you can kind of just mentally visualize a cash flow diagram. We have an outflow for the cost, but then an inflow for the salvage value. So that lump sum of 2,000 is 5 years in the future, and we want to find the annual equivalent of that. So you can either get 2,000 5 years from now, or what's the annual equivalent of that? So equals PMT, and we'll reference this rate. N is 5 years. And now this 2,000 is not a present value. It's not at time 0. So I'm skipping over the present value field. I'm going to click on this minus of the salvage value. It is a future value that I want to convert to A. Okay. So you can either take 2,000 5 years in the future, or 392 every year, and that changes based on our guess of the interest rate. So, you know, this function is referring up here to the guess interest rate. So if I change it to 2%, I'm going to get a lot of different numbers. The annual equivalents have changed, as well as this annual equivalent of the salvage. So the annual equivalents of the cost and the salvage have changed. So let me put it back to 1%. Now, sum of the annual costs. So I've called this X, that Y, and this Z. These pseudo variables here. So the initial cost has been annualized. The annual operating costs were already given on an annual basis. And now the annual equivalent of the salvage value. So each year, I need to make that column a little bit wider. Each year, option A has an equivalent cost of $4,344. And same thing, I can just add them up over here. So it's initial cost, annual equivalent, annual operating costs, and now the annual equivalent of the salvage value is a non-zero value. All right, and now in here, I want to find the difference between these two. It doesn't matter if I do B versus A or A versus B. I just want that difference eventually to be down to 0 through goal seek. So let me just do this minus that. The reverse would have worked for us as well. So we have some difference that's not yet at 0, and we want it to be 0 by changing our guess of the interest rate. So let's see if 2% gets us closer to 0 with that difference. Yes, and 3% getting warmer, 4% getting warmer, but slowly. Let's see, what if I jump ahead to 20%? Well, now it's changed signs, like I've overshot. So it's less than 20. Now, of course, rather than just hunting and pecking and trying to iterate that manually, let me do it in an automatic way using data, what if analysis, goal seek, and then my objective is I want the difference to be a value of 0. And what it should change in order to make that happen is it should change the interest rate. So I'm going to click up here in the location where I'm defining the interest rate. And when I click on enter, or I guess I'll click OK, then it's very quickly going to start changing around the interest rate until it finds some point at which the interest rate brings that difference in costs to 0. Okay, so I'll click OK. 12.65%. Did anybody else get that same value when you were going through? Okay, got some yes there. Good. Excellent. So that's not too hard, right? Simpler than some of the other things we've done this semester. Let's take a look at the homework, because you have a homework that is due, if I remember correctly, what is it, next Monday? Let's just see if we've covered everything on the homework that you're going to have to submit next Monday. Okay. Here it is. All right, so problem 1, external rate of return. Well, I know that we've covered that. In fact, we did it twice. We did it on 2 successive days, and so if you don't remember how to do the external rate of return, I think that we saw that on class 20 and class 21. External rate of return, okay. This next one, incremental internal rate of return analysis. And so that's what we did in class last time, the incremental internal rate of return analysis. And so you've got 1, 2, 3, 4 options. And remember that procedure where the first thing we did was we put them in order of cheapest on the left and gradually increasing on the right. Now this is a table that's just telling you the initial purchase price, net annual revenue, so you're going to have to turn that into a row by row cash flow table, and all of these alternatives last for 10 years. And so just think about how you're going to have to transform the data that you're given into the same format that we used in the in-class exercise, where each row represents a different year, and then you're going to do the initial screening, because your company's MAR is 8%. So the initial screening will tell you which alternative is maybe to be rejected even without the incremental analysis. And then among those that remain after the initial screening, then you do that head-to-head matchup. And you can only do one at a time. You know, for instance, if you're doing Polycore versus Cetera, you don't know which of those two will come out on top. So that's your first comparison, but the second comparison between Salazar, it could be Polycore versus Salazar, or it could be Salazar versus Cetera, and you don't know which one until after the finding of the first comparison. So just remember, don't make the mistake of setting up all of the incremental comparisons at the beginning. You just have to set them up one at a time. All right, so this next one is also incremental analysis, but this one is the annual worth, which is what we just did. And there's one component to the example that we were looking at today that I guess we didn't answer this question. We found the internal rate of return, but you have to choose A or B. If your company's MAR is 9%, which is best? So do you remember decision criteria? If your rate of return on the increment is 12% and your MAR is 9%, which alternative should you choose? Anyone willing to take a stab at explaining that one? Should you choose option A or option B, and why? How do we know? What is the decision criteria? I know somebody out there is brave. We've got 34 people in the class right now, and somebody knows how to make the decision of whether it should be B or A. And I'll just write what the MAR was. Our MAR is 9%. for a MAR of 9%. Should we choose the cheaper alternative or the more expensive alternative if our MAR is 9%? Cheaper? I guess you had a 50-50 guess, but unfortunately that's not the right answer. It's not the cheaper one that's better in this case. So let me show you why as a two-part kind of explanation. So the first part, like, what is the delta I star? What does that represent? The 12.65% is what? The extra amount required to obtain the more expensive alternative earns a rate of return of 12.65%. So the difference between option B and option A, the extra amount that you have to pay for the more expensive alternative, you're getting more than 12% rate of return. So I'm not talking about option A as a whole or option B as a whole. I'm talking about that's the rate of return on the increment, on the difference in price between them. And so think about it this way. If you could go to the bank and you could borrow money at 9%, maybe your MAR is set at 9% because that's your weighted average cost of capital. Maybe 9% represents what it costs you to acquire the funds. But if you could go to the bank and get a loan and you agree to pay the bank back 9% interest, but you can take that money and invest it in something that yields 12.65%, would you take that deal? Would you borrow money at 9% if you're going to earn 12%? I'd take that deal. In fact, I'd spend every possible dollar I could. I mean, I'd borrow as much as possible and I'd invest as much as possible because the difference between what you pay and what you get, those are your profits. And so for a MAR of 9%, which alternative should you choose? Since the delta I star is 12.65%, and that is greater than the MAR of 9%, then you should choose the more expensive alternative. So the converse of that is if the rate of return was less than the MAR, then you choose the cheaper alternative. You know, assuming this is a mutually exclusive choice, you have to either choose A or B. The do-nothing alternative isn't an option for us. We're going to go for one of these two things. Which should we choose? Well, since the MAR is 9% and our rate of return on the increment is more than that, then you choose the more expensive alternative. And that was the same decision criteria that we applied last time in the incremental rate of return analysis, that any time you're earning more than the MAR, choose the more expensive option. Okay, so that's the general criteria. The general criteria if you can earn more than the MAR, choose the more expensive alternative. All right, so any questions about that? Any questions about the application of those ideas? So is that it for the homework? No, there's also a couple of bond problems here just to keep you fresh. So you've got external rate of return, incremental internal rate of return, incremental annual worth analysis, and then two bond problems. So I think that'll go pretty quick. You know, now that we've been through these first three, within just the last recent days. And then the bond ones, you've been getting a trickle of bond questions through the semester. I don't think it'll take you too long to finish this assignment. Well, okay, that's all I have for you today. For once, we're actually going to finish a little bit early. Just remember that the homework assignment is due on Monday, and we do not have class on Friday because it's spring break. I don't know what you're going to do for spring break. I'm going to get wild. I'm going to go into the woods and cut down trees. This trail that I like to run on just got decimated from the recent ice storms, and so I'm going to be chainsawing all day long today. Yes, Mitchell, you do have spring break. It's a one-day spring break. The university will be closed on Friday. So I hope you all enjoy it, and I know that I will. That's it for today. I'll see you on Monday next week. Take care, everybody.